So this video lecture will be on molar conversions. Molar conversions require two pieces of information that you have learned previously. The first are molar masses, and those are calculated from chemical formulas and using the periodic table. It has the units of grams per mole, and the equivalent statement can be written as 1 mole is equal to the mass of your chemical formula. The other piece of information you need is Avogadro's number. And you found out Avogadro's number is 1 mole is equal to 6.022 times 10 to the 23 particles. Now in the past we've talked about particles, and particles can either be molecules or atoms. You will end up using one or the other or both depending on what the question is asking you to convert. So let's begin with gram to mole and mole to gram conversions. The two conversion factors, molar mass and Avogadro's number, we actually have to look at the units. So when we're going from grams to moles, the only one that has grams in its units are molar masses. So we're not going to be using Avogadro's number. So we need to know the molar mass of the given element, molecule, or compound that's given to us in the problem. So we'll take the first example in your notes. It says that we want to convert 5.35 moles of sodium chloride into grams of sodium chloride. So the first step is determining the molar mass of sodium chloride, and which you've learned in another lecture. And so here's the molar mass of sodium chloride, 58.44 grams per mole. Now, I'm going to write it in an equivalent statement, meaning that I'm going to write it 1 mole is equal to 58.44 grams of sodium chloride. This is important for me to see where I'm going to put which unit when I write my unit conversion. So when we're doing our unit conversion, the first thing we have to do is look at the unit given to us. So we have moles. That means we have to look at the equivalent statement and write it in the appropriate conversion factor. That means if I take moles, in order to cancel it, moles has to be on the bottom of your fraction and grams is on the top. This way, moles cancel out and all you're left with is grams. Okay, now you can go ahead and plug in to your calculator and you should get the following. 312.654 grams of sodium chloride. But in order to get the correct answer, you need to also have the correct sig figs. Remember, whatever you start with is whatever you end with. And so when we do the round, your final answer should be 313 grams of sodium chloride. So in the previous example, we went from moles to gram. So in this example, we're going to go from grams to moles. In this example, we're going to be converting from 1.23 grams of argon to moles of argon. The first step, we need to find the molar mass of argon. Since this is an element, we just have to look on the periodic table. The molar mass from the periodic table of argon is 1 mole of argon is 39.95 grams. So again, we're going to go ahead and start with 1.23 grams of argon. So we need to take the molar mass, the equivalent statement, and write in the appropriate conversion factor. So when we make our conversion factor, we're trying to cancel out grams. In this case, that means that we are going to have grams on the bottom and moles on the top. That way we can cancel out grams and left with moles. You should get 0.03078849 moles of argon. But again, we have to look at correct sig figs. This has 3, so we need to round our final answer to 3 sig figs, and you should end up with 0.0308 moles of argon. Now that we've completed doing examples for grams to moles and moles to grams, let's go ahead and take a look at moles to particles and particles to moles. Since we are looking for particles, this time instead of using molar mass, we're just going to use Avogadro's number. So we don't have to look for or calculate the molar mass at all. When you're going from particles to moles, all you need is Avogadro's number. So it's just a quick reminder, when I talk about particles, particles can stand for either atoms, molecules, or compounds. So in this example that I've given you, it's 5.345 moles of sodium chloride, and I'm trying to figure out how many molecules of sodium chloride I have. So the first step I would do is write my equivalent statement in the correct conversion factor. I'm trying to cancel out the unit moles. So when I look at my Avogadro's number, that means I have to have moles on the bottom and 6.022 times 10 to the 23 particles on the top. I can go ahead and plug this number into my calculator. Again, be very careful when you put this into your calculator. And you should get the final answer to be, with the correct sig figs, the following: 3.22 times 10 to the 24 particles. Now that we've done an example dealing with moles to particles and particles to moles, it should be relatively simple compared to going from grams to moles, because all you need to know is Avogadro's number. Go ahead and do the practice problems in your worksheet. And in the next example, I'm going to go ahead and go over how to go from all the way from grams to particles. So this time, let's look at what we need in order to go all the way from grams to particles. Since we're going from grams and want to go to particles, this time you don't need just the molar mass or Avogadro's number. You need to have both of them. Okay? So you will have to calculate the molar mass every time you go from gram to particles. So this example looks very similar to the first example that we went over, going from grams to moles. We are going to go from 5.35 grams of sodium chloride, and instead of going to moles, we're going to molecules. So the first thing we need to do again is calculate the molar mass of the given element, molecule, or compound. So, just like in the first example, the molar mass of sodium chloride is 1 mole of sodium chloride equals 58.44 grams of sodium chloride. But since we don't stop at moles this time, we're going to go to molecules. We also need one more piece of information, and that is Avogadro's number. So we're going to go ahead and start. Now that we have our two pieces of information, the molar mass and Avogadro's number, we're going to go ahead and start with our given. Okay, we're given 5.35 grams of sodium chloride. Since we have grams in the unit, we need to use molar mass first. And since grams is what we're trying to cancel out, this value in gram goes on the bottom of our conversion factor. Okay, now that we've given our grams and converted to moles, we need it now to go to particles, which is molecules. So this is the Avogadro's number is where the next conversion factor we need. Since mole is on the top, mole from the conversion factor needs to be on the bottom. And so our setup should look like this. And now you should be able to put this into your calculator and get the following answer. 5.51 times 10 to the 22 molecules of sodium chloride. So, to summarize molar conversions, I'm going to give you a graphic organizer. In this graphic organizer, you can see the conversion going from mass, which is grams, to moles, to particles, and backwards. So when you're going from just grams to moles, this is what you're going to focus. So if I'm going from grams to moles, I'm going to use molar mass on the bottom and 1 mole on the top. If I'm going from moles to grams, I'm going to have molar mass on the top and 1 mole on the bottom. When I'm going from moles to particles, I'm going to focus here. So moles to particles, I'm going to use Avogadro's number, and that's on the top, while 1 mole is on the bottom of the conversion factor. And from particles to moles, I'm going to use 1 mole over 6.022 times 10 to the 23. Now, if I'm going to go ahead and go from grams to particles, I need both the molar mass and Avogadro's number. And backwards, I need Avogadro's number and molar mass. I hope this tutorial and video lecture has helped in conversions. Please try the problems in your packet, and we will do some exercises in class.